but it's a real piece of precision engineering too.
From the moment we launched the kit to make the first internal module, right through to the engine being dispatched, it's 20 days.
The fan blade delivers 75% of the engine's thrust. It shifts about 1.2 tons of air per second when it's at full throttle.
After about 30 seconds, you've got to come away. You can't stand there too long. If you do, you just start burning.
Every bit of this is all put together by hand.
We used to fit a bolt, it was wrong, the aircraft was to come down.
We run thousands of hours of testing. An explosive detonation releases the blade from the disc at max takeoff speed and fires it into the fan case. The engine is destroyed.
Derby is Rolls-Royce. You mentioned Derby, everybody says Rolls-Royce.
They do better well than I, better customer than I. They don't need my voice.
Morning. That's the inspection department, very friendly people there.
It's a very tough competition with one of the most powerful and competitive companies in the world in General Electric.
It's not until you see Trent Fleet fly over. I've made my own good bit of that.
Today, you know, we're the lead. We're the most efficient engine flying in the world.
This is the Boeing 787 Dreamliner. Designed to be the most fuel-efficient jumbo jet ever, it's touted as the future of air travel.
Even in sort of a grey Seattle day, that paint job is beautiful.
After years in development, the plane is finally ready for its very first flight. The weather's atrocious, but it's a make-or-break moment for Boeing's first new airliner in 10 years.
So you know our plane is taxiing, and so we're proceeding inbound. I'm switching to...
And no one's more gripped than these engineers watching live over the web in Derby. Because they have designed and built the plane's groundbreaking jet engines, using technology that'll save each plane £3 million a year in fuel. If the flight goes according to plan, Rolls-Royce could find themselves building the greenest, cleanest engine for many of the world's airlines, and securing orders in a highly competitive industry. The engine includes some of the most advanced aviation technology the world has ever seen. This is the story of how a British company leads the world in building the most advanced jumbo jet engines, and of the people who build them. Rolls-Royce jet engines are built at state-of-the-art factories all over the UK. It's a huge operation, with orders worth over £40 billion in civil aviation alone, and employing around 11,000 people building them. A new engine must roll off the production line every 36 hours.
Morning, Kev.
Morning, Johan.
All right, mate.
This week it's my turn, but I tend to be more times in a suit than not.
Wow, actually I could have been building one of these in maybe a few months, or designing one of them. Maybe one day.
There you go. That's it. Look at that beauty. It's a work of art.
Rolls-Royce's main assembly plant is a vast 300-acre complex of factory buildings in the southwest corner of Derby. The city has been home to Rolls-Royce for 100 years. And for many of the 250,000 people who live here, the company is a way of life, in work and play.
They ensured me that they would arrive today. About 12 years ago, I joined the Rolls-Royce Ladies Choir. We rehearse every week on a Monday evening at the Rolls-Royce Leisure Association. It's a real enjoyable evening after a day at work.
For many of those who work at the company, Rolls-Royce and Derby go back a very long way.
I was born and bred in Derby, so I've been in Derby 53 years.
I've been at Royce's 36 years. It's like a family business as well. My wife works at Rolls-Royce.
Without Rolls-Royce, I'm unemployed, you know, so it means a lot to us. Well, I think it means a lot to Derby, full stop, really.
You look up to Rolls-Royce, I bet there's not anybody really that doesn't know somebody that works at Rolls-Royce.
40 years. Since I was 18, I joined Royce's. I actually worked on Spitfire, the Merlin engine.
The choir's been in existence for 50 years. We celebrated the 50 years last year and had a big concert to celebrate that.
Years and nearly 6 months. They sang at my wedding, and which was very nice, and I came back with my daughter when she was 11 days old, and she sat in a pram and rocked all the while we were in it for months.
Derby is Rolls-Royce. We've got lots of other engineering companies, but you mentioned Derby, everybody says Rolls-Royce.
The company used to be most famous for its luxury cars, but that all ended in the early 70s. Today, Rolls-Royce cars are actually made by BMW. The company's real heritage is aircraft engines. In fact, they've powered some of the world's most iconic aircraft, from Second World War fighter planes and the Harrier jump jet to the much-loved Concorde. And that heritage continues today, powering helicopters, business and military jets, and even ships. But the star product is the pioneering family of Trent jet engines, including the newest Trent 1000 for the Boeing Dreamliner. All the Trent engines are designed for jumbo-style wide-bodied airliners, like Boeing's 777 and the famous Airbus Super Jumbo. But this engine, for the Airbus 330, is the biggest seller of all. In 15 years, the Trent 700 has clocked up 13 million flying hours.
It's a massive machine, but it's a real piece of precision engineering too.
Weighing at least 5 tons, each Trent engine is worth several times its weight in silver. Only 2 companies in the world are capable of building engines this good.
It's a very tough competition between one of the most powerful and competitive companies in the world in General Electric. And if you look at all the latest new technology aircraft, all have selected Rolls-Royce engines to power the first flight.
It carries a payload of 242 tons at 37,000 feet for 9,500 miles, which, as you can imagine, is a serious challenge for any technology to deliver. So it really is at the high end of manufacturing and assembly. And I often describe what we do as producing things of beauty.
But the popularity of the Trent 700 is also the factory's biggest challenge. With orders placed to build 400 new engines, the company has to produce at least 4 a week. For their production line, one of the most complex in the world, time is big money. Each Trent engine is built from modules, 8 separate sections which are put together on the assembly line. But each module is made from thousands and thousands of components. And the monumental task of gathering them starts here at their massive parts warehouse.
On average, with my pedometer, I average about 8 miles a day. on an average day, but if we have lots and lots of issues, my best is just under 16 miles in a day. Lots and lots of shoe leather used.
Kevin Carr's job is to make sure every engine part is delivered to the assembly line on time.
I do know the guys around here say, you know, you just give me a part number, show me a box, and I can tell you what it is and where it goes. Everything's footprinted, ready for the guys. It's a bit like a sweet shop for them. They can pick and choose what they want. We supply the very first nut, bolt or washer that they fit, right up to the very last little bit of plastic that we put on the engine before it goes out the door to the customer. So that could be anything up to 30,000, 40,000 parts, depending on which engine it is.
It's Kev who kicks off every new engine build. 2 days before the assembly begins, he triggers the dispatch of tens of thousands of parts from the warehouse.
So now it's 8 o'clock.
Have we got all the bits there for it?
Yes.
Got all the paperwork?
Yes.
Yeah, so we're all ready to go then. OK, thanks very much, Noel. Looking at the boxes, you wouldn't know, but just looking at the odds and sods that are lying on the floor, there's nothing under £1,000. You've got the engine control management unit, roughly £750,000 worth in that box, just sitting there on a pallet. Anything up to £200 million worth of stock on the shelf. We have roughly 5 engines worth of stock of anything.
Some of the components that make this engine what it is were designed and built by some of Britain's most skilled and innovative engineers at Rolls-Royce. Nestling in the Lancashire Hills, 100 miles north of Derby, Barn Oldswick is where the first ever jet engines were developed by Sir Frank Whittle. And today this small community still plays a very special part in the building of every Trent engine. Raw materials arrive at the factory every day. Solid sheets of high-grade titanium. They're destined to become one of the components that make Rolls-Royce Trent engines truly unique.
When you walk onto a plane, you look into the engine, that's the fan blade, and that's what we make here.
Mike Wallace's job is to transform the raw metal into high-performance fan blades.
The fan blade delivers 75% of the engine's thrust. It shifts about 1.2 tons of air per second, and the loading on the blade is something like 90 tons centrifugal load when it's at full throttle.
That's like hanging 13 double-decker buses off each of the 20 blades. The enormous fan is what distinguishes a modern jumbo engine from older turbojets. They didn't have a fan at the front and relied entirely on the jet exhaust to thrust the plane forwards. Faster than a propeller, but inefficient and very noisy. But in a turbofan, like a Trent engine, the energy of the exhaust is harvested to turn the massive fan blades at the front, which in turn push huge amounts of cold air quietly around the sides of the engine. And that's what thrusts the plane forwards. The Trent fan blades are unique.
So, which section is this?
And it's all down to their design.
The original blades used to be solid, but in order to get better performance, take weight out of the engine, it was designed to be hollow, and our manufacturing processes, which is unique, has actually enabled us to make that and advance the technology within Rolls-Royce.
Every single fan blade is worth as much as an average family car. For each blade, 3 sheets of metal are bonded together to make a solid titanium sandwich. It's a process so secret it can't be shown on television.
Rolls-Royce is one of the world's leading engineering companies, designing and developing high-technology power solutions based on very efficient engines. These are used for applications on land, at sea and in the air. Our engineering strength is built on 2 key technology platforms, the gas turbine and the piston engine. So how do they work? In the case of the gas turbine on an airliner, air is sucked in via the large front fan. The majority of the air is directed around the engine as pure thrust. The rest enters the engine and is squeezed through compressors consisting of a series of blades. Pressure increases at each stage as the air is squeezed. In the combustion chamber, the air is mixed with fuel and ignited. The hot air explosion is directed towards the back of the engine, generating more thrust and rotating the turbines, which in turn are linked to the front fan and compressors. A piston engine also operates by air being compressed and mixed with fuel. Air is drawn inside a cylinder, then compressed by a piston and mixed with either diesel or liquefied gas. As the mixture ignites, the energy created pushes the piston to the bottom of the cylinder. The piston then returns to the top in a continuous process. Rods connected to a crankshaft convert the vertical movement of the pistons into a rotating motion. As a result, the piston engine can power a wide range of applications: electrical generators, ships, vehicles and railway locomotives. Efficient power on land, at sea and in the air.
Developing its own automatic transmissions for over 50 years. Each of the up to now 5 transmission generations set benchmarks in terms of comfort, vehicle dynamics and reliability when they were launched. An important element of this success story, the Mercedes-Benz automatic transmissions have, right from the start, always been produced at the Stuttgart-Heidelfingen location. There, experienced employees install more than 1 million units every year in state-of-the-art production facilities. Development goal for the new automatic transmission was to significantly reduce the fuel consumption while further increasing the comfort and driving pleasure. The Mercedes-Benz engineers worked on the evolution of the 7G Tronic for 3 years. A highly motivated team reworked the transmission one part at a time. Countless test runs were carried out on the prototypes under the most severe of operating conditions, which allowed for a detailed further improvement of the transmission. The result of this development work is impressive. The new 7G Tronic Plus on its own allows for fuel savings of ½ a litre per 100 kilometres. This corresponds with a reduction of up to 17 grams of CO2 per kilometre. The high fuel saving is achieved through a wide range of innovations which significantly increase the transmission efficiency. The most important new development is the torque converter. In lock-up mode, it establishes an even more direct connection between the vehicle drive system and transmission. In this connection, an almost slip-free transmission of force reduces the friction losses, which are unavoidable in an automatic transmission, to a minimum. In the open converter mode, in contrast, the clearance of the clutch discs is now fully utilized due to compulsory spacing. In this way, the braking power is decisively reduced and an optimal cold start is possible. The result, more of the available engine output is at your disposal for driving. The innovative centrifugal pendulum damper was developed so that this direct connection would also work with the new highly turbocharged engine generations with the usual smooth operation. Movably mounted pendulum mass elements compensate for the uneven running characteristics of the combustion engine. A simple yet effective innovation for maximum smooth running characteristics and driving pleasure. Mercedes-Benz has developed the transmission oil with the lowest viscosity worldwide in order to achieve greater efficiency in the overall transmission. Friction losses in the transmission have thus been decisively reduced. Countless countless design details in the transmission had to be reworked and new materials used in order to be able to benefit from the advantages of the new oil. A technical endeavour which has been worth it. The new automatic transmission achieves a significantly higher degree of efficiency than its predecessor. The 7G Tronic Plus is now also equipped with a start-stop system. In the case of the fuel-saving automatic switch-off of the engine, the new electromotive auxiliary oil pump engages and maintains a basic oil pressure in the transmission. When the engine is restarted, the transmission is thus immediately ready for use. The fuel consumption is thereby further reduced. The electro-hydraulic control unit was also fully reworked in order to obtain better shift dynamics. An eco-shift program takes full advantage of the good power delivery of modern engines in the low-speed range and the improved damping due to the new converter. With these innovations, the new 7G Tronic Plus has achieved a significant reduction in fuel consumption of approximately 7%. A consumption reduction of up to 11% is possible in combination with a start-stop function. Due to its modular design, the new